Hi viewers, today our topic is on electromagnetic radiation. So what is meant by electromagnetic radiation? So electromagnetic radiation is a type of radiation which consisting of a number of waves combination. So each and every wave has a specific function with a specific wavelength and a specific energy. Okay? So why we have to study this electromagnetic radiation in this session means this electromagnetic radiation is a wide range of applications in medicinal field as well as in technology field and whatnot. It will be useful in all kinds of sectors in nowadays. Okay. So coming to electromagnetic radiation, so electromagnetic radiation is abbreviated as EMR. E stands for electro, M stands for magnetic, R stands for radiation. So electromagnetic radiation, so consisting of different different waves. So what are those waves? So it will includes it will includes radio waves, radio waves, microwaves, microwaves, infrared rays, infrared waves, next UV waves, next visible waves, next X-rays, next gamma rays, gamma rays. So how we will memorize all these waves? So in order to memorize all these waves, we have a mnemonic like radio, Michi, I love you, Xerox gun. So what is that mnemonic? Radio Michi, I love you, Xerox gun. So that is the mnemonic we are using to memorize this electromagnetic radiation. R for radio means radio waves, Michi for microwaves, I for infrared rays, U I love means that indicates love you. U means visible. V means U means UV. V means visible. X rays. Gun indicates gamma rays. So these are the waves. So in order to memorize these waves, so the best mnemonic is Radio Michi I love you Xerox gun. So coming to applications of these waves, radio waves are used in NMR spectroscopy. Microwaves are used in rotational spectroscopy. Infrared rays are used in FTIR spectroscopy. UV waves are used in U visible spectroscopy, both these combination of two waves. And X-rays are used in X-ray diffraction spectroscopy. Gamma rays are used in gamma spectroscopy. Okay, gamma spectroscopy, gamma spectroscopy. So each and every wave having a definite role in that spectroscopy. So, what is the function of NMR? What is it do? Means NMR, it is used to estimate carbon content as well as proton content. So, in order to determine the compound carbon skeleton as well as proton content, that proton content and carbon content can be estimated by using NMR spectroscopy only. So, rotational spectroscopy. So, rotational spectroscopy is a kind of spectroscopy in which microwaves are used in order to estimate rotational of the bond is measured in microwave spectroscopy. So, infrared spectroscopy. Generally, infrared waves are used in FTIR, Fourier transformation infrared spectroscopy. So, in this spectroscopy, functional group can be estimated. In UV visible spectroscopy, conjugation or aromaticity can be estimated. In X-rays, X-ray diffraction, compound crystallographic nature can be identified. Gamma spectroscopy. So generally, gamma spectroscopy, which is a kind of spectroscopy which has more applications in medicinal field also. Okay. So uh, coming to applications point of view. So coming to applications point of view, applications, application point of view. So electromagnetic radiation is a wide range of application. First thing, in microbiological, in microbiological point of view. So in microbiological point of view, electromagnetic radiation are used for the purpose of sterilization. Are used for the purpose of sterilization. This is an important bit. And in medicinal field or in medical field, electromagnetic radiation, generally two types of rays are used. One is X-rays and another one is gamma rays. Gamma rays. So generally X-rays, which is used to determine bone fractures, which is used to determine bone fractures, bone fractures, and gamma rays, which is generally used for the treatment of cancer, that is nothing but chemotherapy, which is used in chemotherapy. And the third application, in technology application. In technology, electromagnetic radiation is used in technology means in the point of view any instrument like that instrument, ion instrument. So generally we are very well known with sonicator, right? Sonicator 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 is one of the instrument which is mainly used for the removal of um, gases from the mixture. So that is nothing but degassing procedure as well as size reduction, and the same time what is that solute, uh, proper mixing of solute in the solvent. So and at the same time lysis of the cell membrane. Okay. So sonicator has a wide range of application. So in sonicator, so mechanism involved in sonicator is mechanism. What is the mechanism of electromagnetic radiation in sonicator means? So first of all, electrical energy, electrical energy is going to convert it to mechanical energy. Mechanical energy. From this mechanical energy, it will convert what is that? Vibrational energy. Vibrational energy. So whenever we keep the sample in the sonicator, so when we switch on that sonicator means it will generates electrical energy to mechanical energy. So then sound will coming from that, vibration of the sample will generated. In that vibration, cavitation will be formed. So cavitation will be formed. So during cavitation, micro bubble formation will be takes place. Micro bubble formation will be takes place. Micro bubble formation will be takes place. So this micro bubble formation will expands, and whenever the micro bubble will get expand means it will get burst. Then release of energy will be takes place. Then release of energy will be takes place. Release of energy will be takes place. So like this, the solvent like this sorry the solute is dissolving in the solvent. So this is the mechanism involved in the sonicator. So mainly in this sonicator, one of the ultrasound waves are used. So that is nothing but sonochemical radiation is simply used in this sonicator. So, and coming to next application, coming to next application. So in spectroscopy, generally spectroscopy. So whatever we have studied from the beginning point of view, so all those are involved in this spectroscopy only. So spectroscopy means whenever the electromagnetic radiation interacting with our matter. Matter means our sample, whether the sample might may be liquid or solid or semi-solid or whatever it may be. Whenever electromagnetic radiation interacts 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 with our sample, that is nothing but our matter. Our sample might may be a liquid state or solid state or whatever the state it might may be. So finally it will generate a spectrum. It will generate a spectrum. So from that spectrum we have identified so which molecule it is. So based upon the spectrum which is obtained from different spectroscopic technique, so the data will be variates. Okay, for example, if it is IR spectrum, so then we can estimate in that IR spectrum functional groups will be estimated. Okay, if the spectrum from NMR means from that we can, if it is carbon 13 NMR or proton NMR, from that we can estimate carbon skeleton. Or it is an whatever the obtained spectrum is from NMR, that is proton NMR, from that we can estimate proton content also. So like this, a different type of electromagnetic radiation applications will be there. So first application is electromagnetic radiation, which is used in microbiological. In that microbiological sterilization point of view, we are used generally we use it sterilization as a U visible radiation are generally used for sterilization, and sometimes gamma sterilization, which is nothing but cold sterilization. Okay, gamma rays are used to kill the microbes. Okay, so all these are the uh, electromagnetic radiations used in a sterilization point of view. In medicinal point of view, X-rays, which is used to determine the bone fracture, and at the same time gamma rays, which is used in the cancer treatment. And in technology point of view, best example we take one instrument, and generally that is sonicator. In sonicator, electrical energy is converted to mechanical energy. From that mechanical energy is converted to vibrational energy. So whenever the vibrational energy created in the sample, it will causes cavitation. So cavitation means holes forming microbubbles. Okay, it will expands and it will get burst, then the release of energy will be takes place. Then the solute will be dissolved in that appropriate solvent, right? So coming to another application that is used in spectroscopy. So electromagnetic radiation is widely used in spectroscopic techniques like NMR, UV, IR, X-ray diffraction spectroscopy, so etc, etc, etc. So in the spectroscopy, we are obtaining a data from the spectrum by using this electromagnetic radiation. So whatever I was discussed right now is regarding electromagnetic radiation. So we have said that mnemonic may what is that mnemonic mean? We have said that mnemonic what is that mnemonic means? Radio waves, microwaves, microwaves, infrared, UV, visible, next X-ray, X-ray, next gamma rays, gamma rays, like this. From moving to radio waves to gamma rays, there is an increased in energy, increased in frequency, as well as increased in wave number, and there is a decrease in wavelength. From all these four parameters, we can write one relation, that is, energy is directly proportional to frequency, and these both two parameters are directly proportional to wave number, and these three parameters are inverse relation to wavelength. So this is the relation we are obtaining from this uh, electromagnetic radiation. That means, which of the following rays is having highest energy beams? Gamma rays. And this gamma rays is also having high frequency and a high wave number. And gamma rays is having a less wavelength. So this is the relation we are obtained. So coming to energy point of view, energy. So energy is a different forms of energy like kinetic energy, potential energy. So different forms of energy will be uh, known by us. So during spectroscopic technique, during spectroscopic technique, so while we are using this electromagnetic radiation in the spectroscopic technique, what are the events will be takes place? Mainly, I was discussed in this video only. Okay. So first of all, radio waves, radio waves, radio waves. So initially, I was saying that radio waves is having a less energy when compared to gamma rays. Gamma rays is having highest energy when compared to all the other waves, right? So that means radio waves is having energy is very less. So due to it is having less energy, whenever radio waves are used in the electromagnetic, whenever the radio waves are used in the spectroscopic technique, that is nothing but NMR. So in that NMR, what will happens means, generally this is an atom, this is a nucleus, right? So this is a nucleus and this is an atom. So nucleus is consisting of neutrons as well as protons. Neutrons as well as protons. Neutrons is having a neutral charge, that is nothing but zero charge. Protons is having a positive charge. So overall nucleus is having what type of charge means, which is having a positive charge, that is due to protons only. Okay. So in that atom means what it contains means it contains shells. In the shells it contains subshells. In the subshells it contains orbitals. In the orbitals it contains electrons. What it contains? It contains electrons. So whenever the electromagnetic radiation hit the atoms, these atoms is contains an outermost electrons, right? Whenever the outermost electron, whenever the radiation is crossing from outermost electron, then it hits to nucleus. The nucleus is having a protons and neutrons, right? The protons is having a positive charge, that means it is having some kind of a spin, right? So whenever electromagnetic radiation can be represented in the form of a wavy arrow. Wavy arrow. Wavy arrow means which carries which carries some amount of energy that is nothing but photons in the form of packets. Photons in the form of packets, that is nothing but quantum. Quanta or quantum, right? So wavy arrows indicates for a carrying of photons, right? So this is generally used in spectroscopic techniques when this electromagnetic radiation or wavy arrow which will hits the nucleus. So nucleus is having somewhat of spin, whether it may be a positive spin or negative spin. If it is positive spin means it will it will positive spin means it will upward spin, it will negative spin means it will downward spin, or it will be plus 1 by 2 or it will be minus 1 by 2. So therefore electromagnetic waves, that is radio waves used in NMR, when these electromagnetic wave, that is nothing but radio waves, hits the nucleus of the atom, then spin of that protons will be determined, right? spin of the spin of the spin of the protons will be estimated in NMR spectroscopy. So when compared to UV, 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 what will happens mean electronic transitions will be takes place. Electronic transitions. Why electronic transitions will be takes place means when compared to radio waves, UV rays is having much more amount of energy. That means it will causes something which is more effective when compared to radio waves, right? So in this, whenever UV waves, UV rays hit the atoms, these atoms contains uh, cells, subshells, orbitals is having electrons. So what will takes place means transition of electrons. So movement of electrons takes place from this is lower energy level, this is higher energy level. So high energy means what will happens means it is high energy means what will happens unstable energy is inversely proportional to stability. If it is having more energy means if it is having low stability. If it is having more energy means which is having high reactive capability also. High reactive capability also. So these are the relations, right? So this is the lower energy level, this is the higher energy level. Higher energy level is also known as unstable energy level. Lower energy level is also known as stable energy level. So if we consider an atom in the ground state, lower energy level is also known as ground state also. Ground state level. So whenever our electromagnetic radiation hits the ground energy, ground state containing an atom, in this atom is having somewhat of electrons, right, in the outermost orbital. So it will moves to higher energy level because it will attains or it will gain some amount of energy from this wavy arrow, because this wavy arrow is carrying some amount of photons. So from that higher energy level, it will reach us to ground level. After the energy will exist in that higher energy state. So see this, two events will be takes place. One event is whenever the atom present in the stable state, it will absorb some kind of energy while taking a radiation source, and it will move from higher energy level to lower energy level. So what will happens means it will absorb some kind of energy. So that energy is nothing but absorption. So that is nothing but absorption. Whenever it will attains higher energy, after getting energy it will reaches to higher energy state. After some point of time it will again reaches to ground state or lower energy state because it loses some kind of energy. So whenever it loses the energy after attaining high energy state, that loses of energy is nothing but emission. So this is the difference between absorption and emission. Absorption will be takes place whenever the electromagnetic radiation is absorbs the radiation source from that particular radiation and moves from higher energy level to lower energy level to higher energy level. And after some time from higher energy level to lower energy level, they will reaches to ground state. So release of energy will be takes place, and simultaneously absorption of energy will also be takes place. So in terms of spectroscopy, we terms as absorption spectroscopy. In terms of emission spectroscopy, it will be termed as an emission spectroscopy. So these are all the different kinds of uh, radiation sources and relations. So events, what are the events will be takes place like this. So if we are deriving an energy formula, so we know that Planck's constant E is equals to h nu. So we are having a formula energy or velocity, which is frequency, and another thing is wavelength. So in order to get energy or velocity, E is equals to frequency, which is multiplied with wavelength. So we get the formula for frequency means energy or velocity, which is divided with the wavelength. So whenever we get the formula for wavelength, means wavelength is equals to energy or velocity, which is divided by frequency. So these are the formulas involved in it. So from this formula, we can write E is equals to hc by lambda. So these are the formulas involved in this type of radiation sources. And in IR spectroscopy, electronic, what is that? Vibrational movement of the bonds in the form of vibrational form. All this will be takes place, right? Thank you for watching this video. So thank you.